Okay, let's unpack this critical first step.
Yeah.
For anyone involved in forensics or criminal justice, well, the integrity of a case involving biological evidence, DNA, blood, saliva, and uh, all comes down to the initial actions taken right there at the crime scene. This isn't just theory. This is really the playbook for turning potential evidence into facts that hold up in court.
Precisely. And for you, the learner, it's vital to grasp that the integrity of every single lab test afterwards, every DNA profile, every blood typing result, it completely relies on the methods used in these very first moments. A forensic investigation with biological evidence, it always kicks off with four key pillars: scene security, careful documentation, rigorous collection, and of course, preservation.
Right. And it all starts with the very first person who arrives, often a police officer who might not even be a forensic specialist. Their first job is just immediate containment, isn't it?
That's exactly right. The immediate step is to secure and protect that scene. So that means putting up barrier tape, maybe posting guards, and this is critical, starting a strict log sheet. That log sheet tracks everyone authorized who comes in or goes out. If you're not on that log, well, legally you weren't there.
Okay, so once the scene's locked down, the investigators arrive, and then the priority shifts, right? It becomes about the safety of the people actually going into the scene.
Right.
We're talking biosafety and controlling contamination.
Oh, absolutely non-negotiable. Investigators have to put on a full set of personal protective equipment. I mean, everything. Face masks or shields, safety glasses, those disposable coverall suits, gloves, shoe covers, even a hairnet. You're basically building a sterile bubble around yourself and protecting the scene from yourself.
Why such intense protection, though? What are the specific dangers they're shielding themselves from?
Well, they're protecting themselves from some really serious infectious bloodborne pathogens. We're talking about HIV, hepatitis B and C viruses, even aerosolized tuberculosis in some situations. Exposure can happen through mucous membranes, skin contact, or, needle stick injuries, which can be a real risk in places like clandestine drug labs. Following these protocols isn't just about personal safety, it's also about preventing the investigator from becoming, well, the biggest source of contamination for the evidence itself.
Okay, so scene secure, investigators protected. Now comes the challenge of actually finding the evidence.
Yeah.
How do teams figure out what to look for and what's most important, especially at a complex scene?
Yeah, recognition is absolutely critical. Evidence needs to be evaluated based on its relevance to the case and its probative value, how much it can actually prove something. We give the highest priority to evidence linked to the corpus delicti.
The Latin term means body of crime.
Right. Exactly. The corpus delicti is the physical proof that a crime actually happened. Finding the victim's blood at a scene where the victim themselves is missing, that establishes the crime, say a homicide. That kind of evidence is top priority.
But evidence usually needs to do more than just prove a crime occurred, right?
Yeah.
It needs to connect the dots, tell a story about who was involved, linkages.
Yes, precisely. Evidence establishes connections. Investigators are looking for things like victim-to-perpetrator linkage, maybe fibers from the victim found on a suspect, and also perpetrator-to-scene linkage, like a drop of the suspect's blood or maybe a hair left behind. This whole approach, it really stems from a foundational idea in forensics, the low-card exchange principle.
The classic, every contact leaves a trace.
Correct. It basically states that whenever someone has physical contact with an object or another person, there's a cross-transfer of material. That's why trace evidence, things like hairs, fibers, even skin cells, is so incredibly important. It demands really thorough searching, not just at the scene, but often of the victims and suspects too.
And sometimes the evidence doesn't just link people to places, but it can link one crime to a whole series of crimes through the modus operandi.
The MO, yeah, the pattern of the crime. It refers to a specific, often unique way a crime is committed. The source material gives a pretty chilling example. Richard Carringham, the so-called torso killer. He had this distinct pattern dismembering victims, taking limbs and heads, leaving the torsos, and then setting the rooms on fire. That very specific, unusual MO becomes like a forensic signature, linking those serial cases together.
So once investigators know sort of what they're looking for, the next hurdle is actually finding it, especially when it's tiny, maybe microscopic or even invisible. That brings us to search methods and the tools they use.
Finding biological evidence often comes down to, well, illumination. We relied heavily on something called an alternate light source, or ALS.
That's the device that uses specific light wavelengths to make biologicals glow.
Exactly. It causes materials like blood, semen, saliva to fluoresce, to basically light up. This makes searching much faster because the evidence literally stands out, showing investigators spots they might have otherwise completely missed.
And there are chemical tests too, right? We often hear about phenolphthalein or leukomalachite green for quick, presumptive blood tests. But what if someone tried to clean the scene up?
Right, that's where you might bring in more specialized reagents like luminol or fluorescein. These are chemiluminescent or fluorescent chemicals used specifically to find latent or very faint blood stains. Think faint bloody footprints or drag marks someone tried to wash away. But, and this is a big caution, these tests aren't super specific. Things like bleach, rust, even some plants can cause a false positive reaction. So any hit needs confirmation back in the lab. Always.
The technology keeps advancing too. For really difficult searches like buried bodies, there's ground-penetrating radar, GPR.
Yes, GPR uses electromagnetic waves to help locate things underground, like clandestine graves or buried objects. It's a powerful tool. And while other methods like cadaver sniffing dogs are used, it's worth noting the source points out their reliability for um, legal admissibility isn't as clearly established as something like GPR, which highlights that difference between an investigative tool and court-admissible evidence.
Speaking of high tech, the source mentioned something potentially revolutionary. Portable, field-deployable instruments using rapid DNA technology. Getting a profile from a cheek swab right there in under 2 hours.
Oh, it's a major game changer. Speed is often critical in investigations. This allows law enforcement to potentially identify suspects much faster or quickly determine if, say, a series of break-ins might be linked to the same person right there on scene instead of waiting days or weeks for lab results.
Okay, moving from finding the evidence to recording it. Documentation sketches and photography. Why is this so vital if you're collecting the actual item anyway?
Because the physical item gets removed, often forever changing the scene. The documentation sketches, photos, videos, it's what preserves the context. It records the original condition, the position of things, the spatial relationships between evidence items for later review, especially for the court. Without that context, the evidence can lose a lot of its meaning.
And the photos need to tell a specific story using different views.
Exactly. You need three main types. First, the overall view, the wide shot of the whole scene. Then the medium range view, which shows the relationships between different items of evidence within the scene, gives context. And finally, the close-up view, showing the details of the specific piece of evidence itself. Critically, these close-ups must include a scale like a ruler, or sometimes a special fluorescence scale to accurately show the size of things like bloodstains or bite marks. And every photo needs to be meticulously logged.
Right, which brings us to maybe the most critical part from a legal standpoint. Chain of custody, along with collection and packaging. This feels like where science meets strict legal procedure. What exactly is the chain of custody?
It's essentially the life history of a piece of evidence documented. It's recorded information detailing every single time that evidence is handled, analyzed, or transferred. There's usually a specific form, and every single person who takes custody of that item has to sign and date it. Every single one.
And if there's a mistake here, the consequences are huge.
Devastating is the word. An incomplete or broken chain of custody. It immediately raises the possibility of tampering or contamination, and the result. That evidence, no matter how scientifically valuable, could be deemed inadmissible in court. The whole case could collapse because of a process failure.
Okay, so the paperwork has to be perfect. Then comes the actual collection. Before anyone starts swabbing or scraping, what are the absolute must-dos?
Well, first, things like bloodstain patterns need to be thoroughly documented before you collect samples from them. That documentation is crucial for later crime scene reconstruction. Second, if an item needs multiple types of analysis, you always do the non-destructive tests first. For instance, you'd analyze the fingerprint ridge detail on a bloody print before you collect the blood for DNA. You only get one shot.
And given how sensitive DNA testing is now, I assume you collect pretty much everything, even tiny specks.
Absolutely. With modern PCR techniques, even barely visible stains can yield a profile, so yes, collect it all. And here's a really crucial rule, often missed by beginners. Wet evidence, like a blood-soaked cloth, must be air-dried thoroughly without using heat before it's packaged.
Why the strict no-heat rule? Seems like a hairdryer might speed things up if you're in a rush.
But rushing with heat is exactly what you can't do. Heat accelerates the breakdown of proteins and, critically, the nucleic acids, the DNA itself. Using heat could literally destroy the very evidence you need. It's a classic case where following the correct procedure is far more important than speed.
Makes sense. So for collection methods, we're talking things like swapping surfaces, cutting out stains from fabric, maybe scraping dried blood into clean paper using that special druggist fold for trace evidence, and getting known reference samples too.
Yes, exactly. Techniques vary depending on the surface and the evidence. Swabbing, usually with a moistened swab, followed by a dry one, cutting, scraping. And you always need known control samples for comparison, like blood drawn into an EDTA tube from a victim or suspect, or buccal swabs for saliva standards. And those liquid samples, like blood tubes, they need to be refrigerated, but never ever frozen. Freezing makes the liquid expand, which can crack the tube and lead to contamination or loss.
And finally, packaging. The rules here are all about preventing that degradation you mentioned.
That's right. First, markings investigator initials, case number, item number should never be put directly on or too close to the biological stain itself, or say a bullet hole to avoid interfering with later lab analysis. For packaging materials, dry biological evidence absolutely requires porous materials. Think paper bags, paper envelopes, cardboard boxes.
And the big warning sign we always hear in training.
Is that dry blood-stained evidence must never be sealed in airtight plastic. Plastic traps moisture, even residual moisture, and that creates a perfect environment for bacteria and mold, which rapidly degrade DNA. For tiny trace evidence, like hairs or fibers, you use that druggist fold, a specific way of folding paper to securely contain the sample before putting it inside a labeled envelope or bag.
Okay, so after all that meticulous collection, documentation, and packaging, we get to the final stages, the final survey, and then tying it all together with crime scene reconstruction. The final survey is like a last check.
Exactly. It's the last walkthrough before the scene is officially released. The entire team reviews everything one last time, make sure nothing was missed, check that all the documentation, especially that chain of custody, is complete and accurate, take final overall photos. It's the final quality control step.
And connecting this whole massive effort back to the ultimate goal, it's all in service of crime scene reconstruction, figuring out scientifically what happened.
Precisely. Reconstruction is the scientific process used to determine the sequence of events that occurred during the commission of a crime. It really follows the scientific method. You start with formulating a question like, where was the shooter standing? Then you gather all the information, notes, photos, reports. You construct a hypothesis. You make predictions based on that hypothesis. Then you test it, perhaps through bloodstain pattern analysis or trajectory analysis. Finally, you analyze the data and draw a conclusion.
And that conclusion tells you if your hypothesis holds water based on the physical evidence.
Right. If the experimental data supports the hypothesis, then you develop a theory about that aspect of the crime. If the data is inconsistent, well, you have to discard that hypothesis, formulate an alternative one, and start the testing process over again. It's iterative.
So wrapping this up, what does this all mean for you, the listener? We've journeyed through the absolute necessity of scene security and biosafety, the power of Locard's principle for linking things together, the impact of tech like ALS and rapid DNA, and the make-or-break importance of the chain of custody. Getting these initial steps at the crime scene right isn't just good practice. It's often the foundation upon which the entire legal case rests.
And thinking about that, it raises a really interesting question for the future, doesn't it? Considering how strict and paper-heavy the chain of custody rules are to ensure legal admissibility. How might these new field-deployable technologies like rapid DNA start to challenge or maybe even streamline those requirements? If you can generate a DNA profile almost instantly at the scene, how does that change the traditional paper trail for evidence transfer and handling? That's definitely something to think about as this technology becomes more widespread. Thank you for taking this deep dive with us today.
We really appreciate you sharing your sources with us. Happy learning.